Welcome to Cambridge Chemistry channel with Sarvati Ahmed. In this video I will solve paper 4 alternative practical 5070 for 1 October November 2024. Let's start. Question number 1. A teacher investigates the electrolysis of molten lead to bromide. Lead to bromide is a solid at room temperature. Figure 1.1 shows the apparatus the teacher uses. So molten lead to bromide is taken in crucible and heat this salt. Heating is continuous and when the electrolysis is carried out. So this is crucible and this is power supply and lamp plus negative. This is anode and this is cathode. Name the pieces of apparatus labeled L and M. Suggest the material from which L and M are made. Name electrodes. Material is graphite. Describe the appearance. Graphite is inert electrode, so that's why we will use teacher uses graphite electrode. Describe the appearance of the products at L and at M. L is the negative electrode, cathode, and at anode silvery lead is deposited under the cathode, while at anode bromine gas, orange brown gas can be seen. So describe the appearance of the products at L at M. Appearance of products at L is silvery lead, and appearance of product at M orange vapors of bromine. The teacher stops heating and allows the lead to bromide to cool. Explain why the lamp goes out. Lamp goes out because lead to bromide is solidifies, so current cannot flow in solid lead to bromide because ions are fixed in ionic compound, so current cannot flow in the solid salt. Question number 2. A student titrates 4 samples of 0.800 mole per dm cube aqueous sodium hydroxide with aqueous ethane diacid. In titration 1, the student rinses and fills the burette with aqueous ethane diacid. Uses a volumetric pipette to add 25 centimeter cube of sodium hydroxide to a conical flask. Add thymolophthalene indicator to the conical flask. Places the conical flask on a white tiles. Add aqueous ethane diacid from the burette while swirling the flask, adding drop by drop near the end point until the solution just changes color. The student repeats the titration 3 more times. Figure 2.1 shows the burette readings of the 2 titrations. So this is the burette reading. Final burette reading for titration 1 is 21.1 and this is 0.2 and volume used is 20.9, and for titration 2 initial reading is 21.3. This is 21.3 and this is 41.8. So the volume used is 20.5. So this is third reading is 20.1 and 0.0. 20.1 is the volume used. 40.4 and the initial reading is 20.5. The volume used is by subtracting initial from the final reading, that is 19.9. So these are the more closer values. The difference between this is the less than 0.2. So these are the best titrations. So the part B is take the 2 best titration results in the table 2.1. Just take C. Use the tick titration results in table 2.1 to calculate the average volume of aqueous ethane diacid needed to neutralize 25 centimeter cube of aqueous sodium hydroxide. 20.1 plus 19.9 divided by 2, so the answer is 20.0 volume. Calculate the number of moles of sodium hydroxide in 25 centimeter cube of 0.800 mole per dm cube sodium hydroxide. Mole is equal to concentration into volume in centimeter cube divided by 1000, so the concentration is 0.800 into 25 divided by 1000, the number of mole is 0.02. 1 mole of ethane diacid is neutralized by 2 moles of sodium hydroxide. Use your answer to C and D to calculate the concentration in mole per dm cube of ethane diacid. By using mole ratio, we get the mole of ethane diacid. So 1:2, as question says that 1 mole is neutralized by 2 moles of sodium hydroxide. So we have moles is 0.02. So the answer is the mole of acid is 0.0100. So the concentration is mole over volume into 1000, 0.0100 divided by 20 into 1000. So the concentration is 0.500 mole per dm cube. The formula of ethane diacid is C2H2O4.NH2O. 100 centimeter cube of the aqueous ethane diacid contains 6.3 gram of C2H2O4.NH2O. Use your answer from E to calculate the relative formula mass MR of the C2H2O4.NH2O. Mass of C2H2O4 is 6.3 gram. So volume is 100 centimeter cube. So 100 centimeter cube is equal to 0.1 dm cube volume. So mole is equal to C into V, concentration into volume. So concentration we calculated in above, that is 0.500 into 0.1. The mole is 0.0500. MR is calculated by using mass over mole. So mass is 6.3 gram while mole is 0.0500. The MR is 126.0. Use your answer from Fi to deduce the value of N in C2H2O4.NH2O. Give your answers to nearest the whole number. C2H2O4.NH2O is equal to 126. So carbon is atomic mass is relative atomic mass is 12 into 2 plus hydrogen is 1 into 2 number of atom is 1. Oxygen atomic mass is 16. So number of atom is 4. So water, MR of water is 18. So 18 N is equal to 126. So this is 90 of anhydrous ethane diacid plus 18N is equal to 126. 18N is equal to 126 minus 90. So 18N is equal to 36, or N is equal to 36 divided by 18. The number of water molecule is, mole of water molecule is 2. So N is equal to 2. State why the conical flask is placed on a white tile before aqueous ethane diacid is added to observe color change more easily. State why a measuring cylinder is not used to measure 25 centimeter cube of sodium hydroxide in this experiment. Pipette is more accurate than measuring cylinder, so that's why measuring cylinder is not used. Question number 3. A student investigates solid Y and solution Z. Solid Y is a white powder. The test of the student, the tests the student does on Y are shown in table 3.1. Some of the observations for these tests are also shown. Add excess dilute acid to Y in a boiling tube. Colorless solution form. The gas produced is tested using lime water. Lime water becomes milky. It means carbon dioxide is produced. So add excess dilute acid in boiling tube. Add dilute nitric acid to some of the solution from test 1. Then add aqueous barium nitrate. It means this acid is sulfuric acid. So the ions which conform carbon dioxide is carbonate ion. And add dilute to some of the solution from, so it means metal sulfate is formed. And when we add dilute nitric acid to some of the solution from test 1, then add aqueous barium nitrate, so white precipitate of sulfate ions are formed. So it means sulfate ions are present. Add aqueous sodium hydroxide drop by drop to some of the solution from test 1 until a change is seen. Then add excess aqueous sodium hydroxide. White precipitate soluble in excess, giving a colorless solution. It can be zinc or aluminium. Add aqueous ammonia drop by drop to some of the solution from test 1 until a change is seen. White precipitate, then add excess aqueous ammonia soluble in excess, giving a colorless solution. This test confirms zinc ions present in the solution. So aluminum ions are absent. Describe how the gases pass through lime water in test 1. You may draw a label diagram to help answer the question. Carbon dioxide gas passed through from reaction flask by delivery tube in the gas jar containing lime water. So lime water turns milky. This is the reaction tube and this is delivery tube, and this gas jar containing, this is another test tube containing lime water, and lime water turns milky when carbon dioxide gas passes through this delivery tube in this test tube which contain lime water. Describe two other observations the student makes in the test 1. Solid disappear or metal disappears, or solid dissolves. Number 2, effervescence of carbon dioxide gas can be seen. Identify the gas produced in the test 1, carbon dioxide. Y contains an anion. Use the observation from test 1 to identify this anion. So carbonate ions are present. Use the observation from test 2 to identify the dilute acid used in test 1, that is sulfuric acid. Identify the cations in Y using the observations from the test 3 and 4. This is zinc ions. Solution Z is colorless. The solution student thinks that Z contains copper 2 ion. State why the student is not correct, because solution is colorless. Solution Z contain potassium ions. Describe how to do a flame test on solution Z to confirm the identity of this cation. Dip glass rod into the solution Z and then put on blue flame of the Bunsen burner. Blue flame is converted into lilac flame, which confirms that Z contain potassium ions. Solution Z contain ions of group 7 element. Describe a test and the possible results to identify which group 7 ion is present in Z. Add nitric acid in solution Z. Add aqueous silver nitrate. White precipitate confirms chloride ion. Creamy precipitate confirms bromide ion, and yellow precipitate confirms iodide ion if present. Question number 4. Argentane is an alloy containing zinc, nickel and copper. Zinc and nickel both react with dilute hydrochloric acid. Copper does not react with dilute hydrochloric acid. Plan an investigation to find the percentage by mass of copper in powdered sample of argentane. Your plan must include the use of common laboratory apparatus, argentane and dilute hydrochloric acid. No other chemicals should be used. Your plan must include the apparatus needed, the method to use, and the measurement to take. Procedures to ensure that percentage determined is as accurate as possible. How the measurements are used to determine the percentage by mass of copper in the sample. You may draw a diagram to help the answer. Weigh 2 grams of argentane alloy on balance. Put 2 grams argentane in 100 centimeter cube beaker. Add excess dilute hydrochloric acid in beaker to ensure whole mass of argentane react. Left behind copper in the bottom as copper does not react with dilute hydrochloric acid. Filter the solution mixture by using filter funnel and filter paper to remove unreacted copper as a residue. Wash the residue with distilled water to remove impurities and dry the copper. Weigh the unreacted copper on balance. Repeat the above process with same mass and take average mass of copper for more reliable result. And then calculate the percentage mass of copper is equal to mass of copper divided by mass of argentane into 100. You can draw these diagrams for this experiment.